Okay, I'm ready for another installment of cleaning up some student code. So again, this code is great. It works. Plays tic tac toe. Oops, shows the winner, I think, in all the directions. So this is really just about some advice about how to clean up code, some of which is literally just formatting, some of which is a little more different ways to express things. So I'm just going to go through it again. As always, thank you to the student whose code this is. You will probably recognize it, but this should be perhaps useful to any of you to sort of see what some real code looks like and how it might be made simpler. And maybe you can see some commonalities between this code and code you might write. So first thing I'm going to do is I'm going to format the document. That just makes things a little easier. There was some indentation that was messed up, I think, because they had some code that was at the top level and then they added a function, but they didn't re-indent. So it's always a good idea to just reformat. Also, I like to give code a little room to breathe, putting some spaces between things. So I can sort of like the reason we use paragraphs in writing is the same reason we put some spaces between stuff. All right, so this should all still work. I haven't changed any. Oops, he has this clever arrow. If you click off the board, it tries to tell you where you're supposed to play. Okay. Great. So, all right, so let's now take a look at what we've got. We've got max and min, which is the min and the max of the dimensions, width and the height. Draw board. Looks like it draws the board itself, like the grid, and it has this argument borders that says whether or not to include. I assume this, if we change this to 1, it'll put like a box around the whole thing. Something like that. Okay, that seems fine. I'll point out that in this case, the 0 and the 1 is actually used in this loop. I would probably, well, it's fine. It's a little weird to have these magical arguments like 0 and 1, because when you call it, you don't know what's going to happen to that number. And so if this is really more like a Boolean in my mind, so I would maybe change it like this. And then borders and 1 are 0, which is not all that different. But it just makes it the call a little, I mean, the false is still a little bit opaque, but at least you know it's just one of two values, and it's not like something you could pass in 10 and have it mean something. So I don't know, that's a pretty small thing. But in general, when you have something that can only have two possible values, you should definitely consider using a Boolean. Okay, so that all looks fine. This loop, I tend to like to make the loops simple and then do math inside the body of the loop. It's a little bit a matter of taste. But let me look at what this is doing. So we're looping from 1. Oops, I messed that up. That should be extra. All right, borders is only used at one place now. Okay, so 1 minus the borders. Oh, you know why that actually worked? This is because JavaScript is a little sloppy, and it will actually treat a Boolean as 0 or 1, where false is 0 and 1 is true. So we could be, sometimes people refer to this as puns. We could actually have just left it borders and passed a Boolean, and it would have worked the same. I prefer to actually make things the right type. So, but that's why it worked before. Okay, so back on our loop. We're looping from 1, either from 1 or from 0, up to and including either 2 or 3. So I guess if extra is 0, we're looping from 1 to 2, and if extra is 1, we're looping from 0 to 3. So that's 0, 1, 2, 3, or 1, 2. And then edit var plus equals 1. I can just quickly change that. Typically, I mean, there's no reason to use plus equals 1 if you're just incrementing by 1, and in loops it's particularly idiomatic to use the plus plus operator. Okay, edit var is a kind of funny name. Um, I don't know what that means. I mean, of course it's a variable, and edit, I don't really know what's going on there. It's not exactly I, but I is such a traditional loop variable that I would probably rename this I. And I use that rename symbol, so it changed it everywhere. Also, it's a nice short name, so some of these lines got a little simpler. All right. And now it's kind of okay. I mean, maybe I would even make this a little more explicit and do this here where this, well, if we're drawing the borders, the start is 0, otherwise it's 1. And if we're drawing the borders, the end is 3, otherwise it's 2. So we're going from 0 to 3 or 1 to 2. So that's at least, okay, so I haven't gotten actually to like doing all the math, but that's, yeah, so that's pretty reasonable to my eye. All right, and then the last thing I would notice is there's a lot of duplicate, this expression is duplicated several times, so I might do our old trick of change all occurrences. And what is that? That's really like our x1, or no, what is it? So like what I want to do when I'm extracting an expression is I want to think about what's a name, like how is this value being used? And it is the x value, in this case, it's like the left side, and then here it's the left side plus some stuff, and here it's the left side. So I think that is, so I'm gonna copy it, Command C, and then I'm gonna change all occurrences and just change that to left x. And then I'm gonna come up here and say const left x equals that value. And then, what are we doing? Min and height. This expression seems to happen at least twice. So that's drawing a line. Oh, so it looks like this is actually the, no, this expression is used, this is the x value, right? We're drawing a line from height to 0. So this is like the line x. So I can do the same thing, copy, change all occurrences, line x, or let's see. Oh, this is getting a little vertical line x. It's a little bit verbose for my mind, but okay. So now we're drawing a vertical line at a given x value, which is a function of the leftmost x, and then plus this expression, which is basically a third of the minimum width, like the dimension of the board is the smallest of the two. So in this case, it'll be the height. And I then notice that like left x only depends on min and max, and so it doesn't actually need to be figured out each time through this loop. So I can copy that out and move it up here. Okay, so now my loop is figure out the vertical line x, draw a line from height to 0, and then this is, so this first draw line is vertical, the second is presumably the horizontal, and it's going from that left x to, and this is the other reason breaking these out is a little bit, okay, so here's a common expression, copy it, change all occurrences. And so this is the horizontal Y, and then I can say horizontal Y equals the thing I just copied. And now that makes it a little more obvious that these two are just the same thing. And so this is drawing a line from the left side to max divided by 2 plus min divided by 2. So that's the same as what? I'm a little confused by that. It obviously works, but I feel like this horizontal line goes from the left x to the right x, which is the left x plus the width of the board, which we seem to be using, or the dimension of the board, which like here we were using min as that. I think height, this should also probably really be min, because for a couple reasons, one of which is if the height was the bigger of the dimensions, I don't think that would be right. But I feel like this, and this is where I'm like, obviously the person who wrote this might have been conceptualizing things a little differently, but to my mind it's easiest to think of the line as going from a starting x position to an ending x position, and I know the dimension of the board is min, so I would much rather write that as left x plus min, and then it's kind of clear that we're drawing a line from like the length of the line, and I think this will still work, and we can find out. So indeed it does. Okay, so I feel like that's a little simpler. Gotten rid of some common expressions and made variables for them, and it's just maybe it takes a little getting used to. I'm going to change this variable name to be with renamed symbol to vertical x, just to be consistent and a little more concise. Okay, so now we're drawing a line from the vertical x, or on the vertical x, these two values, from the height to 0. So that's, the height is down here, so we draw it upwards, that's fine. And then we draw a horizontal line from the left x on the given horizontal y dimension or position to the min. And so that seems all pretty good to me. Okay, the next thing I'm going to do, oh, and I should delete this comment since it's no longer correct, or change it to true for borders. But now, since it's not quite such a magical value, I don't feel the need, to comment it. Okay, the next thing I'm going to point out, and a lot of you do this, you like define a function and immediately call it. I prefer to have all of the definitions first, and then put the code that actually does stuff down at the bottom. And so I'll just do that as I go, and then we'll make sure it's in the right order. And sometimes the definition of code that does stuff is a little bit nuanced, but clearly drawing the board is a thing that happens like when the game starts. And part of the reason to do that is it's just easier to see what's going on. If it's like definitions don't do anything, they just provide definitions. And then we get those all out of the way, and then using those definitions, we actually do something. And it makes it easier to see like what actually happens if we put it all together. Okay. Kind of along that line, I would put like things that define variables. So constants like this min and max that are basically global and are used in the other functions probably are good up at the top. I'm going to delete this line because I don't know what it's for. But variables that are kind of the state of the program as it's running, like this is representing the board, I assume. I'm also going to put those down here, but before the actual functions that do stuff with them. Okay, so now similarly, we can look and see where these things reference, like where is player one referenced there. So that suggests these actually all kind of go together. Turns is clearly the number of turn, like what turn we're on in the board. First, I'm going to take those two things I just cut. Sorry, I cut those two. I'm going to put them with this. Then I'm going to take all of this, put it down here. The other sign that things are like consts should go first because they're kind of eternal. And then variables that are declared with let are obviously going to be changing throughout. So that would actually argue for this going after that. This is a little bit not super important, but just to show you some common practices. All right, so we have draw board, we have game win, which we'll get to in a sec. I think I maybe commented on this in the pull request for the student who submitted this. Looks like they haven't changed it quite yet. So if I highlight winner, I see that it is referred to here. And if I quickly scan, it seems nowhere else. So really, and it's just actually not like this winner is an object that gets passed to game win, and then one of its properties is returned as the value from win search. So there's no need for it to be global. And in general, it's better to make things local to the function that they're in. So we know that this winner is now only used within this function, and also means that we can probably make it const because within one execution of the function, we only make the winner once. So we make it, we do a bunch of stuff that I'll talk about later in some very long lines to figure out if there's a winner and set some properties on it, but we're not actually changing the winner. Oh, we are changing the winner. Okay, that has to be a let for now. I would not have expected that, but we'll talk about that later. And then having filled it or set it to the proper value, we pass it to game win, which is up here, and then we return its winner property. So making a variable not global also simplifies. We just don't have to, it's one more thing we don't have to think about when we think about the whole program. It's isolated to this one function. And then register on click does a bunch of stuff to figure out what row and column we're in. Anyone of you who've written Tic Tac Toe have tackled this one way or the other. And I would encourage you all to think about when there's such a regular pattern as this. So this is, we're assigning y position from 0, 1, or 2. And we're doing that based on some sort of mathematical comparisons of the y value relative to the height. And so it sure seems like there's maybe a mathematical relationship that we can express directly rather than having to do it with a sort of logical relationship. And so the way I would think of this is like, what is an expression that will give me the y pos directly? And the way I would think of it, and I think if you've watched my much longer video about writing Tic Tac Toe, you've probably already seen me do this, but even just looking at these expressions, we can sort of see. So if y is less than, and again, we're using height here, which I think is not really, well, I guess it is, it is the y position is the height, but it is also, I guess this thing would maybe draw a non-square board if, is that right? We compute the horizontal is always based on the height, in fact. It just happens that on this screen the height is the smaller of the two, so that's okay. I'm not sure that's right, but I'm gonna come back to that. So we'll go with height. We're doing it in terms of height, and so 1/3, if it's less than 1/3 of the height, right? So if this is the whole height where I'm mousing right now, 1/3 of it is 1 row's worth. So this is 0, this is 1/3 of the height. So if it's less than that, it's in the first row. So the y position is 0. If it's less than 2/3, and we've already ruled out that it's not in the first third, then it's in here. And then obviously if it's any bigger than that, it's between sort of 3/3 and 2/3. So another way to look at that is if we took the y value and divided it by, we could write it as 1/3 times height, or more likely I would just write it as height divided by 3. So if we think of it, height divided by 3 is our ruler, like that's this length from 1 row's worth. If we divide our y value by that amount, we'll get some value that's either a little less than 1, a little less than 2, a little less than 3, or maybe a better way to say it is a little more than 0, but not quite 1, a little more than 1, but not up to 2, and a little more than 2, but not 3. So that suggests if we take the floor of that expression, that will give us a value 0, 1, or 2 in exactly the same pattern as this. So that's what I mean by replacing logic with math. There's a mathematical relationship that this logic was capturing, but it can be just expressed more directly with this. And obviously, depending how comfortable you are with this math, this may be super obvious what's happening, or you may have to sort of puzzle it out. But this kind of thing is very common. If you did the images challenges, you did something like this a bunch of times. So this is just an idiom that you should get used to. And even if it's something you do have to puzzle out and try a few examples of, like we can go over here and say, well, what's the height? Okay, so let's pick a number like 33 divided by height divided by 3. That indeed gives us 0.23 if we took the floor of that. Over here in the REPL, that would give us 0. So presumably this is, we can check, 417 divided by 3 is 139. So anything less than 139, so like 133 should still give us 0. It's still in that first row. But if it's, 153, now we're into the second row, but not into the third. So that expression is this expression. So now I'm confident that that works. All right. What happened here? Wait, there is a left x? Oh, aha, that's funny. Okay, I hadn't quite thought of that. When I did the change all occurrences of this expression to get left x, I changed all the occurrences, including ones where it occurred down here, which is not in the same function where I declared this variable. But that actually points out, remember how I moved this variable out of the loop because it wasn't actually depending on any of the variables in the loop? By the same token, this value is not dependent on any of the values that are in this function. It doesn't depend on borders. So we could actually compute this as soon as we know min and max, up here, and just make that a global constant. And that slightly simplifies draw board, except it depends on this global variable, also means that left x will be defined down here. Okay. I think this expression, max divided by 2 plus min divided by 2, I guess I'm now understanding that. That's kind of the right side. So this is the expression that draws those. You can see those funny arrows. So basically, left x is, since max, at least on this screen, is the wider of the, or is the bigger of the width and the height, which is the width, we're using that. So this max and min is really kind of assuming, in fact, that the width and the height have a certain relation, namely that the width is the bigger one. So we'll definitely have to come back to that. But the width divided by 2 is the center of the board, and then we're drawing, I see. So we're starting at the center along the width side, and then we're subtracting the min divided by 2. So if the height is the smaller dimension, we're taking half of that to get back to here. And if we add half of it, we get to the right side. So we could, just for grins, I don't know how often this expression is used. A couple times. All right, so I'm going to copy that. I'm going to change all occurrences. Oops. Got to keep it selected. I'm going to copy that. I'm going to change all occurrences, call that right x. And now we have another variable that tells us, so that now we could, if we wanted, I guess this was where we were using that before. So now that we have that variable, we could change this line to just draw from left x to right x, which is pretty clear. Assuming we have that value computed, we might as well use it. Okay. So this is pretty straightforward. If x is less than the left or greater than the right, that means it's out of bounds, and it draws an arrow in either direction. It's using this ternary operator to figure out which arrow to draw. That's kind of fine. Again, x minus height gives me the heebie-jeebies because x is a dimension on the width, and the height, like, that just seems weird to me. I'm not going to worry too much about that, though. Right, we've got a lot of these, height divided by 3. Okay. Otherwise, so this is kind of the special case. Otherwise, we're going to figure out, and this logic is very similar to the logic we used to figure out the y position, except since it doesn't, the y had the virtue of going from 0 to the height, so we could just like divide the height by 3. In this case, this is basically max divided by 2 minus min divided by 6, I think is getting us there, because if we chop this board into 6 parts, all right, so that does get us to this line. And then the second line is starting at the middle, going 1/6 to the right, and otherwise we're in the last column. So this one is a little more complex, but if we think of it kind of on the same logic as this one, we can see that another way to think about it is if you take whatever x value it is and then subtract left x, then it is as if we're starting at 0. Right, so if we clicked right on the left x, it would be 0. And if we clicked right on the right x, it would be whatever, the width of the board across. And so, and we used min as the dimensions of the board, like the width of the board, not the width of the screen. So it's going to be very similar. It's going to be something involving x divided by min divided by 3. But it can't just be x, because x doesn't go from 0 to min. It goes from left x to left x plus min. So, as I suggested before, if we just subtract left x, that moves the value that we're dividing into the range 0 to the width of the board, and then we divide it by 3. Oops. Sorry, I'm writing this the right way. Okay. X minus left x divided by 1/3 the size of the columns. And I believe, and I put this up here again because I could put it down here, but I suspect we can actually check. And I think I did this when I wrote my own. We can check what would happen if we, so let's see what left x is. Oops, let's run all this. Does it still run? Nope, I broke something. Y pause has already been declared. Oh, sorry. Right. So since we're, this is another pattern to look for, and a kind of a reason to use const is it encourages you to figure out the right value for a thing once, rather than declaring it mutable and then setting it to different values based on logic. If you can set it in one go, then you can make it const, and that's another good sign for your code. Okay, so that type assignment to a constant value. Oh, I didn't delete this. Okay, that seems to still be working, same as before. So my xpos computation is working right. So now we can see what left x is, 211. So if we pick some value that was less than 211 and did, oh, that's actually interesting. What's going to happen? So 200 minus left x. So that's going to be some negative value divided by min divided by 3. That's probably going to give us -1. Yes. So basically, if we get a negative xpos, that means we're off the board to the left. And if we gave it like 50, if we did the other side where we did like, let's make right x plus 50. So that's our fake click, and then minus left pos. Left x. Right, then we get a thing that's greater than 2. So the valid x positions are 0, 1, and 2. If it's negative, it's off to the left. If it's greater than 2, it's 3. And so now we can, I guess this logic, we could do this logic in terms of the xpos rather than in terms of left x and right x, which is maybe a little clear. So like if it's less than 0 or it's greater than 2, all right, so that logic should be the same. Click over, oops, sorry, xpos. All right, that logic is the same. Curious. Oh, wait. Zero, 1, 2. Again, I used x instead of x plus. All right, so when you make changes, you got to actually make all the changes. All right, good. That works. Okay. So this has simplified the code a bit. We've gotten rid of two three-legged ifs and replaced them with a little bit of math. And now the register on click is somewhat more manageable. And so basically, and now we've got it down to like a few definitions. We've got some definitions of some constants that are derived from the size of the board, size of the screen. And then we have a function that draws the board based on those constants. A game win that we haven't really looked at. A win search that we haven't looked at in detail, though I guess we moved this variable inside. And then a register on click that we've simplified to use some math. And then we get to the actual code of define the two players X and O, define this chord array, which I think of as the board. And we have a turns variable that keeps track of what turn we're on, and then the player, which is like the current player, which starts out at player 1 and then presumably up here switches between player 1 and player 2. So that's, to my eyes, already easier to read. And as I've been going through this, I pointed out a couple times that sometimes we're using height, particularly using height as in computations, or sorry, that one is right, that is the height. But where we're using height directly feels to me to be cutting against the idea of getting the min and the max. Because if the height was bigger, then max would be the height and min would be the width. And things like this wouldn't work. So the x computation would work regardless if the screen was taller than it was wide, then we'd be drawing a board that was exactly the full width, but I think we would also be drawing a board that was still the full height rather than being the dimensions of the board. So I am highly inclined, and I think at the moment, like on this screen, changing height to min will just work because height is min. And this 0 is also a little problematic for a similar reason, which is if the height was bigger, then the board presumably should be centered vertically rather than centered horizontally. It would take up the whole width, but would need to be centered vertically. So we would actually need 0 would have to be like, well, where's the top of the board start at? And that would have to be similar to the way we figure out the left x. And then also we have to look at, does left x work properly if these were reversed? Like if this was actually the height, I think that is also okay. So here's I think the lesson. So I think we want to know the minimum. I'm not sure we actually should ever be using the maximum, because the left x is determined by instead of doing it from the center and subtracting, well, actually we could do it the same way, but the left x is always going to be determined by the width divided by 2, i.e. the center along the horizontal dimension, and then subtracting half of the size of the board, which is min. And so I'm going to go ahead and just for a second say board size equals min. And so here, so if we start at the middle of the width and subtract half of the board size, we get to the left side. And then by the same token, if we start at the middle of the width and we add half of the board size, we get the right side. So now this will work regardless. Even if the width was the smaller dimension, then width divided by 2 would be right in the middle, and board size would be actually the width. And so we'd subtract and we get all the way to 0, and then on the other side we get all the way to the width. So that would work properly. And if we say top y, we can that is purely a function of the height. We can do basically the same thing. So same token, the y, start in the middle on the vertical axis, subtract half of the board size to get to the top, add half of the board size to get to the bottom. There's a bunch of different ways you can figure out where all these things are, but those are now written in terms of the width and the height where appropriate and the board size where appropriate. And so let's see, I'm going to do a Command F to search for max, and that's the only place it occurs, so we actually don't need that max. And you can see here another advantage of having broken out those common expressions into these variables. I'd also moved a lot of the occurrences of max to here, and then once I realized that there was maybe a better way to write these, they all got fixed at once. Okay, so now I can look. I just added these top y and bottom y because I was looking down here. So now we should probably also not use min, and maybe so the horizontal y, okay, so this kind of assumes, yeah, so this should be computed similarly to how we computed the vertical x. We should start at the top y, plus really the board size times I over 3. And this min is also the board size. And this starts to make sense because we're drawing the board, and so we should be drawing it in terms of the board size. And then this is the vertical line, so it should go from the top Y to the bottom Y, just the same as the horizontal lines go from the left X to the right X. So that... Now, okay, so we've gotten rid of those uses of min. I was actually looking at something else. Okay, down here, right, we talked about this. So the X position we had to figure out from the actual X, but starting at the left X and going, this is really the board size. And to figure out the Y position also is really in terms of the board size, and by the same token, we have to go Y minus top Y. So we click, if the board didn't actually cover the whole vertical space, then we would have to adjust where we click backwards by the amount of top Y to get the right thing. Now in this setup where the height is a smaller one, top Y should be 0, so we can check that. Top Y and bottom Y probably equals the height, indeed. So it only would matter if the dimensions of the screen changed. And let's see, is there other places we used min? I suspect all of these heights should really be board size, especially when we're talking about X, but really in all cases would be my guess. So that seems to basically work. And let's see, where else are we using min? So this min is almost certainly the board size, board size, board size. Right. At this point, I think everywhere we use min, it's really the board size, so I can actually just go ahead, delete the board size variable, and rename this symbol board size. So all the places that referred to board size before stayed the same, and all the ones that used to be min now say board size. And that should be, so this is not something we can test super easily without changing the dimensions of this drawing area, but I believe this is more robust. That's what that circle does. I noticed that before. Okay, so that's the indicator of a tie. It's drawing a giant. Oh, interesting. That's funny. Okay, so variable names matter. The semantics of it before, I guess we're actually not quite right in that it wouldn't have worked quite properly if the dimensions of the screen had changed. I think now they would. So I think that is another improvement, and an improvement that was a lot easier to see as we made maybe it's the code that got simpler. In some cases it may just be working at a level of detail that I'm doing to make these changes allows me to see things that I wouldn't see otherwise, which is actually an argument for going back and simplifying your code, because you might have written a bunch of code one way and gotten it working or seeming to work, and then just going back to sort of tidy things up gives you another chance to sort of look carefully at the code and think about, are these things named? Do these names still mean what they meant when I first named them? Is there anything that I'm using incorrectly, maybe in a way that works right now but might not work in a more general case? All right. So this width and height are probably fine because these are all like the mid. What are we drawing? It's, oh, I see. This is getting the, yeah, I don't know if this is really in relation to the board or actually in, I mean, it's kind of got to be in relation to the board, but like width divided by, actually width divided by 2 minus height divided by 2, that actually doesn't make any sense. I think this height, again, is the board size. Right, we're going from width, right, we're basically width divided by 2 minus board size divided by 2. That is the left x. Okay, so that escaped. I think because it was written in min before. So, but that really is left x, which makes sense because this is a horizontal winner. So we're drawing from the left x to the right x. That makes sense. And then the actual, this is like the middle of the row. So the height, I see height divided by 6. So that's in this board works because it's the height divided by 6 is like 1/6 of the whole board. Plus height times winner location divided by 3. All right, I'm not really going to puzzle that out exactly, but I assume that gets us to the middle of the appropriate row because that's where you're drawing the horizontal line. By similar logic, that must be what this is doing, and we're drawing a vertical winner, and that should go from the top y all right. Also, these very long lines are very hard to read. So I would actually, first thing I would probably do to try and clear this up is I would, after each of the commas where there's a new argument, and actually before the first one, I would put a new line so I can see more easily how these arguments are divided up. And now I can see that this is going from along a certain vertical axis, top y, so this is where the bottom y should be, gray line, 8 wide. I could do the same thing up here. Also makes it easier to see that the second and fourth arguments are the same as they should be because we're drawing, those are the dimensions that stay the same. So left x to the vertical, or sorry, the horizontal. Coordinate to the right x to the same horizontal coordinate. And then finally, this is the diagonal. Is going to be more complicated, but breaking them out also will let us probably see some that we need to change. So this goes from the same expression we used to figure out the left x and the, not quite, right, because it's, I'm curious actually that it's not the same. So it's going to be the x value and then the y value. I'm going to reformat this. Okay, so the y value is 0, but wherever we use 0, it should really be top y, and wherever we use height, it should be bottom y. That's what I call them, right? Top y and bottom y, right? Because again, on this board, top y is 0 and bottom y is height, but if the height was the bigger dimension, we'd need to change that. Okay, and then it's figuring out I see. So this is either, we're always drawing from top to bottom. So then we have to either draw from over here to the bottom right or from starting up here to the bottom left. And that's why these have a conditional expression in them. And now I think what I want to do is I want to fix all of these. These actually really should be in terms of the board. And the other thing to note about this is it's not just that I'm using different variables that arrive at the same place, but also we are making it robust, so if the dimensions of the screen changed, it would still work. But we're also making it a lot easier if we wanted to draw the same board, but like in a complete, like just like maybe in the top left corner of the screen or the bottom right corner of the screen, or just move it around. The set of things that we would have to change would really just be these, as long as we draw, and board size, I guess, as long as we write everything else in terms of those. So we want to get out of the width and height. Right, we want to use them at the beginning to figure out what these values are, but not use them here where we're actually trying to draw on the board, and the board maybe was positioned differently. So, okay, so now we can figure this out. So this is computing the horizontal, where on the vertical axis the horizontal line goes, and it's doing it by, so the winner location is, I believe, we can just take a quick peek, but I believe is going to be always 0, 1, or 2. And so this is dividing it 0, 1, or 2 divided by 3. Oh, right, so a third of that. So we're going to get 0, 1/3, or 2/3. The height times that. So basically 0 of the height, 1/3 of the height, or 2/3 of the height. I'm sorry, I was doing this one. Same thing though. So the height times that fraction, 0/3, 1/3, or 2/3 will be there. And then adding a sixth of the height gets us to the middle of that. So really, so that height is really board size divided by 6, and that's board size, and then this whole thing is top y plus that. And so I'm going to break out a constant, which is y, or sorry, yes. So the y value for a horizontal win goes here. And that should obviously be the same value. And now that we've, okay, well, let's try this. So let's see if, okay, x, o, x, o, x. Okay, it draws in the right place. X, o, x, o, x. I'm going to be confident that it works. And now I can hit, I think, I'm going to command palette, join lines is Control J. I think it does it from, so now that I've simplified these, I can actually put them back on one line. So if it's a horizontal winner, we compute the y coordinate purely in terms of the board size and the location of the winner. And then we draw a line from the left to the right at that horizontal coordinate. And that's good. And so probably a similar thing can happen here, where we can figure out what the x value should be in terms of this. Oops. Reformat. And we're going to join that up. Join. reformat. All right, but now I want by the same token. So this is board size. So this one is doing finding width divided by 2 minus height divided by 3. Right, so that one was doing the left x oh, but it did height divided by 3, so that got us to there. Okay, so I'm going to regularize it and say, similar to the way we did the y, we're going to do left x plus board size divided by 6 plus, so from there, plus board size divided by 6 gets us there, and then plus either 1/3 or 0/3, 1/3, or 2/3 gets us there. And this math could maybe even be simplified some more, but I suspect that that's good. Okay. And then finally the diagonal is a little more complicated, but just for keep things on one line, I'm going to define some variables. And then x2, join, reformat. And now come up here and say, are these in fact right? Again, this should be board size. This should be board size. I guess this is really right. So the diagonals have this special encoding of 0 and 1. This is being done in a slightly different way, but okay. So let's just, I'm going to do this from first principles. Let's say so the x1, I might have to look at win search and see what. Okay, so if it's a diagonal win, that means it's going from 0, 0, 1, 1, 2, 2. So from top left to bottom right. Okay, so that means our first x, oh, and I think actually, no, maybe it is. So if it's, okay, let's check it out. Let's see. So it's basically, yeah, it really is just the top left. Okay, so if we're going, all right, I'm gonna, like I said, do this from first principles. So const x1, our first x, if it's the 0th winner location, copy that, then it's just left x. Otherwise, I think it's right x. And then by the same token, win loc equals 0 if it's, so if it's location 0, we're going from top left, so left to right. If so, left to right, so that means clearly we have to be going the other direction. Is that just going to work? Yes. Yes. Okay, so that also, so I guess this time I replaced math with some logic, which was if the special diagonal win location was 0, it goes left to right. So really like left to right, otherwise right to left. So in this case, it was simpler to just, and that was partly because I've defined these variables, so I have these handy values of the left side of the board and the right side of the board lying around, so I can just use them when needed. These expressions are a little complicated, but they seem fine. They do the job, and they're only used in one place, so I'm okay with that. I might, if I was bored, come back and try and simplify those. Okay, and so I think my last, well, I always say last, and I'm never is the last, but next thing I would like to tackle is just these really long lines. Look at the scroll bar. It has to scroll basically half again the width of this screen. It is generally a good idea to keep lines at no more than 80 or maybe 100 characters, mostly just so they fit in like a lot of context where you have to look at code, like in an editor window. These days we have big screens. Also, it's just hard to scan really long lines. So the first thing I would do is I would just break these up after the operator, so it's kind of obvious when you get to here that like, oh, this line must continue, because you can't end an expression with an operator like that. And then I would realize that this is an if. I would follow my rule to always put braces around the body of the if, and then I would reformat that. And you can see how it indents these a little bit relative to the if to also make it obvious that this is part of one expression. If it was up to me, I would probably indent them like that, but I think the auto formatter in this case is going to fight me. Let's see what happens if, does it? Yeah, I might format it like that. That's at least. And then the next thing I would do is I would try and make this a little more concise, or in some way, so I don't have to have such a long line. But now I can at least read this code. So I'm going to go ahead and do the same thing with the other two. And I'll break that there. Format. And then this, this, this. Format document. This, this. So here's an editor trick, is if you're trying to insert braces around something, if you type it where there's a space after, it inserts the extra one, which is kind of a pain. But if you have the cursor right before a non-space, then it only inserts one, and then you can put the closing one where you want it. All right. So this is fine. And now we can kind of see, oh wait, did I think I maybe added, oh no, no, okay. Right, so this thing does, using a loop, it checks the 3 possible rows and columns, and then outside of the loop, it checks the 2 diagonals separately. So there's 0, 1, like top left to bottom right, and then top right to bottom left. I think the first thing I would do, since I don't have any great ideas, is coord array. I know that stands for coordinate array, but it's really just the board. So I'm going to rename that to board. Partly because like coordinate array, I would expect would be an array that contains coordinates. And this does not contain coordinates. It contains markers. So that, and also board has the virtue of being a little bit shorter than coord array. Also, I like names that are just words, not abbreviated. The other thing I can do, yeah, so this one is interesting. I like it that it takes the player as an argument, which you might think it might not, because player is actually a global variable. In general, I like to pass things into functions as arguments, even if they are accessible as global variables, just because it makes the functions easier to test on their own and whatnot. In this case, it also gives me this opportunity to rename the symbol to one character, just because these broken up lines are a little hard to read, so I can join them back up. I don't know if that's better or not, but now they kind of fit within the editor. A little better. Okay. So the loop is nice. I'm going to go ahead and change all occurrences of space equals space to add the third equals. Yeah, this is actually fine now that it's a little legible. I mean, you could do the diagonals with a little bit of math too, but it's probably not any more concise, or probably less clear than just doing it kind of by hand here. I guess the only thing I would do is just to try and declutter a little bit. These parentheses are not necessary, which, as I've said, it's always fine to use parentheses to make the precedence clear, but you will get used to you will get used to some of the obvious precedence things, and equals is quite high precedence compared to other operators, or at least compared to the Boolean operators. And the precedence of operators actually tends to go kind of in the order you would expect. Like, it is much more likely that you want to, if you're anding things together, you want to be anding together Boolean values, and therefore operators that produce Boolean values, like comparison operators, are going to be higher precedence, so that you can get the Boolean values you want and then and them together. Whereas if and was higher precedence, then that would imply that you're trying to compare this value to anded together some, like, I don't know, it hardly even makes sense in general. So I will never ding anyone for using parentheses they don't need to do, but as you get used to the precedence of the common operators, you can leave some out, and again, it makes it a little more concise. Maybe it's just a little more what I'm used to seeing, concise and less cluttered. So I think this is fine. The only other thing I would note is all of the bodies of these, I guess they're doing two things. They're setting the player, they're setting the type, and they're setting the location to a different value. So it is actually setting it to all three. The player is the only common part. Actually, I guess so here's this little subtlety. This function checks all of the possibilities, but since it sets winner every time it finds one, the result is, if there were two winners, like if you, let's see, can I make two, what happened? Uh-oh, I broke something. What did I break? Well, that's unfortunate. So should be error messages should come out over here, but sometimes they don't. So I'm going to peek. No, that looks fine. Oh, it's a mystery. What's happening? I changed chord array to board. There wasn't another variable named board, was there, that I clobbered or something? Okay, it was working there. And not working there. I definitely broke something. What did I do? Um, I must have broken something when I was moving all those if statements, breaking those up. But it can't be in WinSearch because I didn't like that. Oh, maybe it could. Oh, wait, maybe. No, nothing there. How on earth? Okay, clicking's working. All right, now you're seeing the real. Okay, what is happening? So we're not even getting to WinSearch. I don't feel like I changed. So I got the click. Oh. Wait, board. No, Y pause, X pause. That should be right. Oh, wait, something is. All right, that worked. Ha ha. I did change the thing. I changed the double equals to the triples equals, but there was actually a problem that I had noticed before and hadn't done anything about yet. I'm going to change this one back to double equals, and I predict it will work. Indeed. So the problem here is that this is not, and this is kind of why I like triple equals over double equals. Double equals is sloppy. So double equals is comparing the value in the board at a given position to the empty string. But the value in the board at the given position, so like row 0 is this whole thing, column 0 is this element, which is an array containing an empty string. So that's this value, which is not equal to the empty string. However, double equals is super sloppy, and I think the reason is because it basically converts it to a string. Yeah, and since so an empty array converts to an empty string. Actually, that does not. But an array of one item that happens to be an empty string gets converted to an empty string, and that then gets compared to the empty string, and that's true. So double equals is just super sloppy, and it was a mistake, and you should never use it. And I have told you that, and this is why. So, I mean, you might say, oh, it worked before, but the reason it worked was not really a great one. So I'm going to put this back, and I'm going to now take this opportunity to fix this code by... It's weird, actually, that like there's 3 levels of array here. The outer board array is an array of 3 elements which represent the rows. Each row is an array, which makes sense because each row has to have 3 sort of cells in it. But then the cells are themselves arrays that happen to be 1 element long and have an equal sign, or sorry, have an empty string in them. So I would much more expect the rows to be 3 element arrays of strings, or I mean, there's a bunch of ways you could represent the empty cell. Since what it was comparing to was the empty string, I think we should just go ahead and use that. And now, and then I'll note that as soon as the board at that row and column gets assigned the player is a string. So this went from an array containing the empty string to the string X, which is another sign that, like, in general, the types of values in an array should usually, not always, but usually be sort of constant. Like if it starts out as an array of strings, it should stay an array of strings. Or if it's going to become an array of strings, it should start out as an array of strings. Sometimes you can get away with using null or something instead of empty string. But here, just make an array. Empty string represents an empty cell. We compare to that, and I'm pretty sure this is going to work. Okay, so indeed, I had forgotten that changing, especially using that change all occurrences, I changed all the double equals to triple equals and had consequently broken code that was depending on the rather sloppy semantics of the double equals operator. So now that I've set the board up properly, we can use triple equals and it works. Great. Okay. So I don't know where I was just going to test it, and I thought it was going to work, and then it didn't, and we had a mystery, and the mystery is solved. I can take out this debugging gorp that I put in to try and get back on solid ground. Also point out, like, this is, like debugging, there's a lot of different ways you can do it, but fundamentally, the problem you're trying to solve is there is a gap that has developed, a slippage between how you think the program works and how it actually works, and you just have to do whatever you can to close that gap. And so you can do that. I tested, put in a console log to make sure that I hadn't, make sure the onClick was getting called. I was pretty sure it was, but if it wasn't, then I would definitely have a bigger problem than I thought. So I put that in and easily saw that, yes, okay, the XY is indeed coming in. Then I put another one in and say, we're still computing X position, Y position properly. Then I put this one in that we never saw before when it was broken, because this was never true. And so then I narrowed it pretty quickly down to, like, okay, when search is not being called, and it's called right there, and I had a console log right here, so I knew somewhere between this line and this, something was preventing this function from even being called, and that doesn't leave very many things. And then finally I remembered, oh, I had changed this from double equals to triple equals, and then I found the bug. So this is, like, a lot of programming is debugging and finding those gaps between what you think and what is true. So it's the scientific method, however you want to think about it, but it's something you're going to get to practice. All right. So I think that is actually kind of maybe the last thing. The drawing the text, I mean, we fixed all the references to the board size and whatnot. These lines are very long again. So I'm going to look for commas and break these up and see if I can maybe format to get indented. Let's see, did I miss? So we get that. Oh, that's right. So we're drawing the marker at the X and the Y, color black, and that. Then we're console logging. So that is presumably for debugging. We could take that out, and then we swap the player. And then finally, there's this. If we get to turn 9 and there is no winner, then we draw the big O, big enough to cover the whole board and indicate that that it's a draw. That seems fine. So yeah, I think that's pretty good. Place to leave it. If you watch my video about writing Tic Tac Toe, the figuring out exactly how to center the letters and stuff, that's more science or more like empirical science than theoretical science. Just gotta eyeball it and adjust, as seems to be happening here. Possibly this math can be simplified, but that seems fine to me. All right. I think that's good. I think I'll leave it there. Thank you again to the student who wrote this code. Hopefully this was helpful expansion for you on the comments I left on your PR. Hopefully for everyone else, it's another opportunity to sort of see how you can, these are all moves that you can make when you are working with your own code. So you can write some code and then you can go back and look for the things that I was looking for here. It's harder to do in some ways with your own code because you, at least if you just wrote it, will understand it all in a way that you'll be like, you won't see the places that it's might be confusing to someone who isn't already soaked in it. But come back to your old code, you might be able to do it, and eventually you'll learn to sort of see things that are less clear than they could be, even if you happen to understand them. So yet again, probably this video was too long, and if you powered all the way through to the end, thank you for watching. Hope you got something good out of it. Take care.